Hello, folks. So here's a homework problem that I thought was interesting. One, because it's not as simple as just throwing in your formulas, and you actually do have to think about it a little bit. But it's also not too bad because that thinking part is actually fairly logical. So let's think about this. And this is just part of a problem. The gist of the problem is that a phone number has, what, 10 digits, right? There's area code and then the 7-digit phone number. But this particular part of the problem that we want to talk about is called the line number, which is the last 4 digits. So if I was to draw a picture of a phone number here, you have your area code. This 3-letter part, there's 3 digits here. 3-digit area code, 3-digit exchange. And here there's a 4-digit line number. That's what this is. The only restriction on the line number is that they cannot be all zeros. Okay? And the question in this problem is how many possible line numbers are there? I want to talk about this problem in 3 different ways. And the first way, actually, you might think it's kind of trivial, but it's important to think like sometimes you don't have to make things super duper complicated. So let's think about this. There's 4 digits. One number that so you can't do 0, 0, 0, 0. This is not okay. We don't want that one. So let's not even count that. That doesn't count. But I could do 0, 0, 0, 1. And I could do 0, 0, 0, 2. So that's 1 right there, and that's number 2 right there. I go 0, 0, 0, 3, and so on. The last number that I could possibly do is, I'm kind of laughing because like it seems so simple, but it's like sometimes you laugh at how you would tackle a problem like there's no way it's this easy, but sometimes it really just is that easy. And like the last one you could possibly do is 9999. The next number after that would be 10,000, but that would be 5 digits in the number 10,000. This is number 3. And eventually, this one would be number 9,999. And that's what the answer actually is. So you don't have to make it super complicated. That would totally work. But how else could I do it? So that's option number 1, or method number 1. Number 2, well, there are 4 slots in your line number, 4 digits. So you can think about this. Let's pretend in this first option, you have the numbers 0 through 9, which are 10 different options. And actually, this would work at any time. So right now in this scenario, I'm ignoring the fact that you can't do all 4 zeros. So at the same time here, there's 10 options there, 10 options, 10 options. Because every slot could be any number between 1 and 9, including, 0 and 9 inclusive. And so that would just be 10 times, because you're picking 1 digit and then you're picking another digit. You would multiply all these. That's important. 10 times 10 times 10, which is 10,000. So there's 10,000 different options, but you have to be aware of the fact now, like what else is the problem restricting us with? Well, we have to still deal with this 4 zeros business. And so this is 10,000 options, but this includes, that includes 0, 0, 0, 0, which we don't want to do. Well, how many 0, 0, 0, 0s are there? There's only one of those. So what we need to do is take that 10,000 and take away, 1 to represent. This is, again, this is the 0, 0, 0, 0 that we're trying to get rid of. And that's how we could get 9,999. The last option is the most convoluted, but definitely shows some expertise with the idea of 2 counting principles. So let's think about this. The last option here, or the last method I'll say, is, let's see, what are we doing? We're looking for the number of ways to, I'll say build a 4-digit number that, or a number or word, if you think about some of the previous problems or previous examples, to build a 4-digit number that isn't built out of 4 zeros. Now, is this not the same equals number of ways? And I'm going to kind of shorten this, but number of ways using 3 zeros or 2 zeros or 1 0, oops, 0 or no zeros. I can't have 4 zeros, but I could have 3, I could have 2, I could have 1, and I could have zeros. And so if these are all ors, then I would just have to figure out the number of ways to do this, 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 and add them all up, because that's how you deal with OR. There's no possible overlap here, so I also don't need to subtract anything, because there's no way you could have exactly 1 0, and by this I mean exactly 2, exactly 1 0, exactly 3 zeros. That's important. So let's think about this. How many ways are there to have 3 zeros? Well, let's just draw a picture here. I have 3 slots there. If I put the 3 zeros, I could think of the 3 zeros 0 0 0 right there in the front. The last one, that can't be a 0. It has to be 1 through 9. And so here there are 9 options. 9 options. So this is kind of hard to, not hard necessarily, but this might be a little bit tricky to think about where could I put the 3 zeros. I could put them in slot number 1, 2, 3, or 4. But another way to think about it, instead of trying to rearrange the 3 zeros, we just think of it as, where do I put the one non-zero? And so I could do that. There's 9 options there. So that would be 9. I could put those 9 options right there, or right there, right there. Okay, so I'm not saying that there's 0 possibilities for these right here. I'm saying those 3 spots are kind of locked up already. So I guess I'll put it, maybe I'll just cross them off, because you can't put the zeros there. These are the zeros. And so how many ways are there to use 3 zeros? Number of ways using 3 zeros is equal to, well, there's 9 here. 9 in the first one, then 9 in the second one, 9 and then 9. It'd be 4 times 9, which is 36. Okay, so how many ways, by the way, this would also be the same for the number of ways to do no zeros. So let's just do that real quick since we're here. So the number of ways to do no zeros, oh, sorry, that's not what I wanted to say. It's this one right here. Number of ways to do exactly 1 0. Because you can do 1, 2, 3, 4. I could put the 0, I could put the 1 0 right here. I could put the 0 right there. I could put the 0 right there, or in the first slot. In which case, there's going to be 4 of them, but in each of those 4 ways, how many options are there for the other 3 slots? Well, this would be 9 there, because again, it would be 1 through 9, 1 through 9, 1 through 9. Oops. So maybe I won't put the zeros there again. I'll put the x's there, because those represent the 0. And these blue slots represent 1 through 9. And so this is 9 cubed. This, again, would be 999. And so the number of ways to use 1 0 is 9 cubed, but again, times 4. We'll do no zeros now, because the 2 zeros is kind of the most complicated. Well, even then, that's not too bad. If I go about with no zeros, this one's nice because it's the easiest one. Well, I don't know, one of the easiest ones to think about is, well, how many options for each slot? Well, since there are no zeros to worry about, every single one is just 1 through 9. So that'd just be 9, 9, 9, 9, or 9 to the 4th. So the number of ways to use no zeros is 9 to the 4th. last part here is the number of ways to do 2 zeros. So I'm going to actually come down here a little bit. So the number of ways to use 2 zeros. Let's see, let's draw the slots. 1, 2, 3, 4. So I'm going to put a 0 here and here, say. And then left over here, well, how many options? Likewise, you have 1 through 9 here, and then 1 through 9 here. And so that'd just be 9 times 9, so that's 9 squared. What else could happen? I could draw, or I could put the zeros, I could put them right there and right there. And then in which case, I still have 9 and 9 for the same reason. If I draw these all out, we should get 6 of them if I did it correctly. So that'd be 0 and 0. Oops. Let's see, x, and then 9 and 9. And now what you can do is kind of just flip-flop all the options. So in this one, the first one, it was the 2 zeros in the front. So now I can put the 2 zeros in the back. In this one, the zeros were in the first and third position. So now let's put the zeros in the second and fourth. 9 and 9. And this one, they're on the outside, so now they're both on the inside. Okay. And I don't think there's any other possibility unless I messed up. But notice here, what was I doing is, and what this is kind of jumping into the future a little bit with combinations, what I was doing was, well, let's just say here, let me just do this real quick. So this is, in each of these, there's 9 squared. So this equals 6 times 9 squared. But where did the 6 come from? Well, think about what we were doing. This 6 comes from how many ways we were able to pick 2 slots out of 4. Now, did we care what order they went in? We totally didn't, because the fact that this 0 goes in position number 1 and position number 2, it doesn't matter if I put the first 0 in the second position and the second 0 in the first position. It didn't matter. Without order mattering. Without order. If we think about that, that is for C2 or for choose 2. And if I did that, that'd be 4 factorial over 2 factorial times 2 factorial. If we simplify this, this would be 24 divided by 4, which is 6. So that's another way to have done that. But in theory, we didn't even know about combinations yet, so this would have just worked out by drawing out the picture. And so if I add up all of these now in yellow, oops, I have plus, plus, plus. If I pull out my handy dandy calculator, 36 plus 9 cubed times 4 plus 9 squared times 6 plus 9 to the 4th, we should get 999 different line numbers. So that's 3 different ways for you to kind of figure out to solve this problem. One way to kind of, and some argue the best solution to a problem is the simplest solution. That would be probably this first one. And I'm not saying one is better than the other. I'm saying the best one, as usual, the best one is the one that works for you and makes sense to you. The second one is using what we know about combinations and kind of, or not combinations, but the number of ways to count repeated or consecutive events. How many ways can I pick a first digit, and then a second digit, and then a third digit, and so on. And the third way is, if you really want to play with, okay, how could I show what I really, really know about all this counting business? Arguably the most fun, definitely the slowest of this one. Okay, so hopefully this was informative and somewhat enjoyable.